In December 1915, at a secret proving ground in the rural area of one European country, a large armored vehicle slowly emerged from the hangar, its appearance distinct from any previously existing machinery. It had a mass of approximately 27.5 long tons, a rhomboid hull shape, and tracks that enveloped its entire length. The officers present observed the demonstrated engineering development. The machine moved at a pedestrian's pace, emitting the noise of a working engine and spewing black smoke. Its notable feature was its ability to traverse terrains inaccessible to other types of vehicles. The engineer's development demonstrated the capability to cross trenches, destroy barbed wire entanglements, and move through areas pockmarked with shell craters. This was the first test of the Mark I armored vehicle, which subsequently changed the nature of warfare and received the code designation Landship Centipede. However, not everyone present shared the enthusiasm. War Minister Lord Kitchener expressed the opinion that this undertaking was impractical and constituted an unwarranted waste of resources. The development of this machine had begun a year earlier amidst the positional stalemate on the Western Front. Millions of servicemen were in the trenches. Any attempt at an offensive resulted in significant casualties under machine gun fire. One of the belligerents needed a fundamentally new means to break through enemy defenses. A group of specialists, including William Tritton and Walter Wilson, began developing an armored tracked vehicle. The first prototype, known as Little Willie, demonstrated insufficient cross-country mobility. In response, a decision was made to create a rhomboid hull with tracks running along its outer contour. The total length of the machine, including additional tail wheels designed to aid in crossing wide trenches, reached nearly 33 feet. Tests conducted in April 1916 simulated real combat conditions. For this purpose, trenches approximately 11.5 feet wide were specially dug. Shell craters were simulated, and a multi-row barbed wire entanglement was set up. The armored vehicle approached the first trench, its front section extending over the gap. Then, the machine slowly tilted forward, and its tracks gripped the opposite edge. After a few seconds, the machine crossed the obstacle. The barbed wire was crushed beneath its tracks. The shell craters were overcome by the machine without visible difficulty. Most of the officers expressed a positive assessment of what they saw, but Lord Kitchener maintained his previous stance, characterizing the machine as an expensive and inefficient means, unsuitable for real combat operations. Despite the War Minister's skepticism, the project received support at the highest level of leadership. On February 12, 1916, an order was placed for the first batch of 100 machines, and on April 23rd for an additional 50 units. Production was organized at William Foster's factory in Lincoln and at the Metropolitan Carriage and Wagon Company. The machines were produced in two modifications, conventionally called males and females. The male modification was equipped with two 6-pounder naval guns mounted in side sponsons and 3 machine guns. The female modification was armed with 5 machine guns, 4 of them of 303-inch caliber manufactured by Vickers, and 1 heavy machine gun located in the hull. Such a division was dictated by tactical objectives. Gun-armed machines were intended for suppressing fortifications and strong points. Machine gun-armed machines were to be used for engaging enemy infantry units. A significant problem was the engine. The 6-cylinder Foster Daimler gasoline engine developed a power of 105 horsepower. With the machine weighing 28 metric tons, this provided a specific power of 3.7 horsepower per metric ton. This figure is considered low. On flat terrain, the machine could reach speeds of up to 4 miles per hour, and on rough terrain, the speed significantly decreased. An additional factor was the engine's placement in the same compartment as the 8-person crew. Exhaust gases, high temperatures, and oil fumes created extremely difficult conditions inside the machine. Temperatures reached 122 degrees Fahrenheit. The crew faced loss of consciousness, asphyxiation, and carbon monoxide poisoning. However, the command considered these conditions acceptable, as the distance between trenches rarely exceeded several hundred yards. It was assumed that within such a short time, the crew would not sustain serious injury. Inside the tank, an 8-person crew operated in conditions of limited space, high temperatures from heated metal, significant engine noise, and the presence of exhaust gases and fumes. 2 drivers performed functions requiring a high degree of coordination. One controlled the gearbox. The second was responsible for the brakes. Both also synchronously operated the mechanisms of each track. Precise coordination was required, but the high intensity of internal noise, reaching a level where verbal communication was impossible, created significant difficulties in achieving it. Crew members wore protective leather helmets with padding, but their effectiveness in reducing noise was limited. Drivers synchronized their actions through gestures and intuition. The remaining 4 crew members operated the armament. In the modification known as the Mail, artillerymen loaded and aimed the 6-pounder guns located in the side sponsons. The presence of sponsons increased the tank's width to 13.5 feet, compared to 8.4 feet without them. Sponsons were designed to be dismantled for railway transportation. However, in combat conditions, they posed an increased risk. A direct hit from a shell on a sponson would lead to the artilleryman being struck by shrapnel and secondary elements. In the modification known as the Female, machine gunners used Vickers machine guns or 8mm Hotchkiss machine guns with water cooling. The commander managed the crew and observed targets through narrow viewing slits. Production of the first machines began in the summer of 1916. The Foster Company released 37 units of the Male modification. Metropolitan Carriage produced 113 tanks, including 38 males and 75 females. The manufacturing process was carried out with significant urgency. The British command planned a major offensive on the Somme, intending to use the new equipment to break through defensive lines. Tanks were transported to France by railway, observing strict secrecy measures. The German side had no information about the existence of these machines. Crews underwent accelerated training, the duration of which was limited. A significant portion of the tank crews gained their first experience driving the machine just a few days before being sent to the front. On September 15, 1916, the first 32 Mark I tanks appeared in the morning fog on the front line between Flers and Courcelette. German infantry displayed confusion at the sight of the moving armored vehicles. Machine gun and rifle fire proved ineffective against the armor. The tanks overcame trenches, neutralized machine gun positions, and created breaches in wire entanglements. German troops retreated, abandoning their weapons and equipment. However, the operational success was limited. Out of 32 vehicles, only 18 reached German positions. The others were halted due to getting stuck in craters, mechanical breakdowns, bogging down in mud, or engine failure from overheating. Several tanks were hit by German artillery, leading to their incineration and the death of their crews. Fuel tanks were located in the front part of the hull. Upon a direct hit by a shell, the vehicle was quickly engulfed in flames. Evacuation from a burning tank was extremely difficult. Narrow hatches were provided in the rear part of the sponsons, but their practical use for emergency egress from the vehicle was associated with significant difficulties. The small dimensions of the hatches and the rapid spread of flames from the front fuel tanks often prevented the crew from reaching these exits. Additional hatches, located above the driver's position and in the rear of the hull, also had limited dimensions and did not provide convenient access. Tank crews continued to perform combat missions despite being aware of the high probability of death if a fuel tank was hit. Being in the confined space of a metal structure under artillery fire, where any shell could cause the tank to ignite, was associated with extreme stress. Mud presented a significant obstacle for the tanks. Research showed that the clay of the Flanders region had high adhesion to metal. The tracks accumulated significant volumes of this mass, which adhered firmly to the steel. Separating the material from the structure required substantial effort. The flat shape of the track shoes contributed to the tank sliding across the surface, but this process was accompanied by the constant buildup of new layers of mud. The tracks became clogged, and tanks fell into craters and got stuck in marshy areas. The 105 horsepower Daimler engine experienced excessive loads. Frequent breakdowns were noted, often affecting several systems simultaneously, including the transmission, running gear, and cooling system. Mechanics made significant efforts to restore the vehicles, but the number of operational tanks steadily decreased. The Mark II model was developed in an attempt to rectify several identified shortcomings. In July 1916, an order was placed for 50 vehicles, 25 units of the male modification and 25 of the female modification. Military command acknowledged that the first model required refinement, so the Mark II was initially intended for training purposes. The question of using soft, unhardened steel in their production is a subject of debate. Some historians suggest lightweight armor intended for training vehicles. Others vehemently deny this, citing the fact that 20 units of the male modification were sent to France to replenish losses. They also point to the unlikelihood of soft armor being quickly replaced with hardened armor, either in production or in French workshops. The central section of the Mark II was somewhat reduced. Engineers planned to install wider tracks to improve cross-country capability, but this decision was not implemented. 5 machines were allocated for experiments with power plants and transmissions. An open competition was announced among manufacturers to improve the design. In March 1917, comparative demonstrations were held at a specialized proving ground. By this point, only 3 Mark II tanks had been completed. Additionally, an older model was equipped with a Daimler petrol-electric system. Testing the Wilson gearbox instead of the secondary transmission demonstrated its significant advantage. The results led to the Wilson system being adopted as the standard for all subsequent designs. By early 1917, it became evident that Mark IV production was delayed. The command decided to utilize all available machines. 25 Mark II training tanks located at the training ground in Dorset, United Kingdom, were transported to France. There, they joined 20 other Mark IIs and 15 Mark Is to participate in the Arras offensive in April. The Battle of Arras was characterized by high casualties among tank crews. By this time, opposing forces had developed armor-piercing bullets for machine guns. The tank's armor proved insufficient. Bullets pierced the steel plates, creating a dangerous internal environment within the vehicles. Metal fragments ricocheted inside the hull, causing injuries and fatalities among the crew members. The Mark III represented another intermediate model, developed as a temporary solution until more advanced designs became available. 50 vehicles were produced intended for crew training. Information on modifications and photographs have survived in limited numbers. It is presumed that the Mark III was practically identical to its predecessors, possibly with similar soft armor, although there is no convincing evidence for this version. The only documented difference for the machine gun-armed variant, the so-called female, was the use of lighter Lewis machine guns in reduced lightened sponsons. Initially, it was planned to retrofit this batch with Mark IV improvements as soon as they were ready, to train tank crews on equipment as close as possible to combat conditions. However, development was delayed and the Mark III tanks were supplied in their original form. None of these machines left the territory of the United Kingdom. In the summer of 1917, Mark IVs, representing an improved version of the first tank, began arriving at the front. Protection was enhanced and fuel tanks were moved from the vulnerable front to a safer location. Production was scaled up significantly, 1,220 vehicles, of which 420 were gun-armed, the so-called males, 595 machine gun-armed, the so-called females, and 205 were supply vehicles. This was the most numerous combat vehicle of the British tank forces during the First World War. The first combat deployment of the Mark IV took place on June 7, 1917, in the attack on Messines. The terrain was scarred with craters, but cold, dry weather allowed more than 60 tanks to achieve partial success. However, they lagged behind the infantry, which advanced without waiting for the slow-moving combat vehicles. Significant difficulties arose later during the Third Battle of Ypres. Torrential rains turned the battlefield into an impassable bog. The Mark IVs became mired in the liquid mud. Their power-to-weight ratio was so low that on the heavily cratered and waterlogged terrain, the tanks lost mobility. The engines overheated, working at their limits in an attempt to extricate the vehicle, leading to their failure. Attempts to free a bogged-down tank often resulted in it becoming a vulnerable target for German artillery or being captured by German forces after the crew was forced to abandon the immobilized vehicle. In November 1917, in the Cambrai sector, 460 Mark IV tanks demonstrated their potential when effectively employed. The terrain was firm, and German defenses, though complex, could be overcome by a sufficient number of tanks for a concentrated assault. The breakthrough was characterized by considerable depth. German positions were crushed to a significant depth. For the first time, tanks were not used in small groups to support infantry, but as an independent strike force capable of breaching fortified defenses. British command recognized that the new weapon required new tactics, precluding the dispersal of tanks in small groups across the front. In the spring of 1918, the German Army launched a large-scale offensive with the aim of achieving victory before the arrival of American troops. British officers recorded that German assault groups were accompanied by tanks, but these were not original German models, but captured Mark I and Mark IV tanks. The number of captured British vehicles was significant, making encounters with original German tanks a rare occurrence. German forces created entire units of so-called Bute-Panzer, trophy tanks, repainted them in their own colors, applied identification markings, and used them against their former owners. British forces urgently needed to develop methods to counter their own equipment. Command ordered the modification of the armament of some Mark V tanks, creating so-called hermaphrodites. A sponson with machine gun armament, female version, was installed on one side and one with cannon armament, male version, on the other. This armament configuration provided the capability to effectively counter enemy armored vehicles and infantry. The first documented tank engagement occurred in April 1918 during the Second Battle of Villers-Bretonneux. 3 British Mark IV tanks, 2 machine gun-only variants and 1 cannon-equipped variant, made contact with a German A7V tank. The machine guns of the Mark IV tanks, equipped with this type of armament, opened fire. However, their firepower proved ineffective as the shells did not penetrate the German tank's armor. After several recorded hits, both Mark IV machines, unable to inflict significant damage on the armored target, withdrew. The cannon-equipped Mark IV tank then engaged the A7V. Both combat vehicles exchanged fire, recording hits, but no critical damage was inflicted on either side. Ultimately, both vehicles concluded the encounter without achieving a decisive result. This event demonstrated the potential of tank warfare as a new element of modern warfare. With the commencement of Mark V tank deliveries to the front, characterized by improved protection, a more powerful engine, and increased speed, Mark IV production ceased. Many of the remaining Mark IV units were converted into supply vehicles. Their armament was dismantled, and the interior space was used for transporting ammunition, provisions, and other supplies for forward units. Several Mark IV tanks came into the possession of white formations in Russia during the Civil War. However, reliable evidence of their combat use is absent. At the same time, captured Mark IV tanks were actively used during the revolutionary events in Germany in 1919. They were employed by government forces to suppress communist uprisings. The Mark V represented the culmination of rhomboid tank development and was the last major British combat vehicle produced during the conflict. Initially, the Mark V was planned as a deeply modernized version, incorporating a significant number of innovations. However, as a result of development, it became an enhanced modification of the Mark IV with improved components. External differences between the machines were minimal, retaining identical parameters for the hull, track chassis, and overall dimensions. Key changes concern the internal layout and mechanisms. The installation of a new six-cylinder record engine with a volume of 19 liters provided a power output of 150 horsepower. The specific power increased to 5.2 horsepower per ton, which allowed the maximum speed to be raised to 4.7 miles per hour. A fuel capacity of 119 gallons ensured the autonomous operation of the machine for approximately 10 hours over rough terrain. A significant innovation was the introduction of a new transmission system, which allowed the number of crew members responsible for driving the tank to be reduced to one driver instead of two. During tests of various systems on modified Mark IV tanks, the clear advantage of the Wilson design was demonstrated, which was subsequently adopted as the standard. This eliminated the need for complex coordination between two operators in high-noise conditions. A single crew member could effectively control all systems. An additional cabin was provided in the rear of the hull, equipped with vision slits and hinged panels for installing auxiliary equipment. Another machine gun mount was added, leading to an increase in the machine's overall firepower. Production of the Mark V began at the Metropolitan Carriage and Wagon Company factories in the autumn of 1917. The first batch of machines arrived in France in May 1918, but its volume was insufficient to significantly influence the course of combat operations. Only by midsummer did the number of produced machines become sufficient for their massive deployment. On July 7, 1918, near Amiens, 60 Mark V tanks led an assault by Australian units on German positions. This operation marked the first large-scale combat application of the new machines, and its results surpassed preliminary estimates. The installation of more powerful engines contributed to tanks more effectively overcoming obstacles. The improved transmission increased maneuverability, and the transition to single-driver control freed up one crew member for other functions. Australian units broke through the German defenses, with tanks neutralizing firing points, creating breaches in obstacles, after which the infantry continued to advance. Resistance from German forces was promptly and decisively suppressed. Attacker losses were recorded as significantly smaller compared to previous operations conducted without massive support from armored units. In August of the same year, a significant success was achieved in the Battle of Amiens. 288 Mark V tanks, along with numerous light Whippet tanks, participated in the operation, which became one of the most successful for the Entente forces throughout the entire war. German forces were caught by surprise by the scale of the tank attack. Their defenses were breached along a wide section of the front. British and French formations advanced several miles deep, capturing thousands of prisoners, dozens of artillery pieces and a significant amount of equipment. The German command called this day the Black Day of the German Army. General Ludendorff concluded that the war was lost, the morale of the troops was undermined, and the available reserves could not change the situation. Mark V tanks demonstrated their effectiveness as a decisive breakthrough weapon. From May to November 1918, Mark V tanks were deployed in 8 major offensive operations right up to the armistice. Tanks became a standard element of British military strategy. No serious offensive was planned without them. Simultaneously, Canadian and American tank crews underwent training on the Mark V. The United States had not managed to develop its own heavy tanks by the end of the war, so American units were equipped with British machinery. The 301st Heavy Tank Battalion of the U.S. Army was fully equipped with Mark V tanks and was deployed into combat from September to November against the Hindenburg Line, a formidable German defensive system. American tank crews displayed resilience, but suffered heavy losses due to a lack of combat experience. Out of 21 tanks, 18 were lost or rendered inoperable within a few months of fighting. German artillery learned to effectively counter armored vehicles. Concentrated fire from field guns quickly turned tanks into damaged or destroyed machines. Crews perished from direct hits, shrapnel, fires, and gas poisoning inside disabled vehicles. Nevertheless, American units continued to attack. Their tanks helped the infantry overcome fortifications that otherwise might have cost thousands of lives in an assault. By the time of the armistice on November 11th, the battalion had sustained significant losses, yet its assigned objectives were accomplished. After the end of the war, the fate of the Mark V took an unexpected turn. The British government decided to support the White movement in Russia, which was fighting against the Bolsheviks. 70 Mark V tanks were loaded onto ships and sent via Arkhangelsk and Vladivostok to the White Guard armies. The British side hoped that modern armored vehicles would help the Whites achieve victory in the Civil War and overthrow the communist regime. The tanks indeed had a significant impact on their adversaries. The Red Army did not possess similar equipment and initially suffered heavy losses from sudden tank attacks. However, the situation on the fronts developed unfavorably for the White movement. Red forces outnumbered them, controlled central industrial regions, and had advantages in supply and replenishment. White armies retreated, lost territories, and more equipment fell into enemy hands as trophies. Each captured Mark V was thoroughly studied, repaired, and deployed by the Bolsheviks against its former owners. Red tank crews quickly mastered the British machines, and mechanics learned to keep them operational despite a shortage of spare parts and qualified specialists. As the White movement weakened and suffered defeat after defeat, the number of Mark V tanks under the control of the Red Army steadily increased. By the end of the Civil War, captured British tanks became the backbone of the Red Army's armored units. The Red Army leadership recognized the value of these machines and sought to employ them in significant operations. In 1921, Mark V tanks were deployed in a number of major engagements on the western borders of the nascent Soviet state. These machines were used in Lithuania and Latvia as part of the Red Army's efforts to establish control and suppress nationalist movements. The rhomboid armored vehicles demonstrated effectiveness as a means of influence and suppressing resistance. Their presence often determined the outcome of combat operations even before the start of intensive engagements. Notably, Mark V tanks remained in service with the Red Army until 1939. Thus, 21 years after their creation and 2 decades after the end of World War I, these slow-moving machines of outdated design continued to be part of Soviet tank units. By the late 1930s, these machines were significantly outdated and could be used primarily for training purposes or as stationary firing points. However, their prolonged service life indicates the robustness of their basic design and the limited availability of more modern equipment in the Soviet Union during that period. The developers of these machines probably did not anticipate such a long service life and use in such diverse conditions. The last recorded combat uses of the Mark V occurred 2 decades after their creation, during a period when the world was preparing for a new large-scale conflict and tank building had achieved significant progress. The rhomboid machines with tracks encompassing the entire hull, equipped with 150 horsepower engines and developing a speed comparable to a pedestrian's pace, evolved from combat units into historical exhibits during an era of high-speed tanks with powerful artillery armament and enhanced armor. Nevertheless, their historical role is considered significant. It was the Mark V tanks that initiated the era of armored forces, demonstrated the effectiveness of tracked armored vehicles, and established the foundations of tank unit tactics. The century-long path of armored vehicle development, from the first models with an 8-person crew to modern combat machines, began with these vehicles, which first appeared on the battlefield in September 1916.